Okay. So just, I don't want to say this one more time because I just realized that I stopped the previous video here and it did not record this. So f of x, natural log of 8x. So we differentiate natural log 1 over the inner function times the inner function prime, which is 1 over 8x, times the further inner or innermost function prime. We simplify and we get that. Okay, so now let's look at some word problems that involve log functions. So this is one if we'd like to, if we're interested in advertising, if we're interested in marginal profit, if we're interested in marginal revenue, if we're interested in forgetting, all these have natural log functions in them. So let's choose.
We do 99.
99 it is. So let's start with 99. So 99, marginal revenue. The demand for a computer, okay, game is, so this is P of X, it's demand. So P of X is 53.5 minus 8 natural log X. Okay. Where P of X is the price consumer will pay. So this is the price in dollars. X is the number of games sold. X, number of units sold. In thousands, okay. Recall the total revenue is given by R of X, yes. And number of units times the price, fine. Find R of X and then find marginal revenue. Is there any price at which revenue will be maximized? We'll see in a moment. Perfect. So first R of X and then the marginal. So they already gave us the formula. So the revenue is the number of units we sell times the price per unit. And the price per unit is this function. So I'm just going to write X in parentheses, 53.5 minus 8 natural log X. And I will distribute correctly negative 8x natural log X plus 53.5x. Then in part B, they're asking us to find the marginal revenue. By definition, this is the derivative of the revenue is called marginal revenue. So now I have to be careful when I differentiate, not here, but here, because I have a function 1 and I have function 2. Please leave negative 8 outside waiting. It will wait patiently and it will not mess us up. So the first function prime is 1. So then I just copy natural log X plus. I copy X, but now I have to differentiate natural log and we know it's an easy situation. Now I get here, and when I differentiate, I just get 53.5. I will simplify, of course, and I get 1. So now, remember, we have to distribute negative 8. So this is negative 8 natural log X, and then minus 8, and plus 53.5. So finally, our prime, the marginal revenue, is negative 8 natural log X, and plus, what is this? Is it 45.5? Correct me if I'm wrong at any point in time. Feel free to correct. There is a part C to the question. Is there any price at which revenue will be maximized? So what do we know from the previous chapter when we talk about maximum? What do I need to determine in order to find whether a function has a max or a min? Of course, the derivative. So I already have the derivative. So in part C, we're asked, first of all, to find if the function has critical numbers and if those critical numbers turn into max or min. If it doesn't have critical numbers, the function revenue will not have a max min. Even if it has critical numbers, there is no guarantee that it has max min. I still have to study the sign. So in order to find critical numbers, I have to set this equal to 0. So negative 8 natural log X plus 45.5 equals 0. I move 45.5, it becomes negative, and divide by -8. So then natural log x is 45.5 divided by 8. And we just solved a couple of equations tonight. So I will convert it. How do I convert this equation? Because I don't know how to solve it. I have to convert it into an exponential. How do I convert it into an exponential?
E to the 45.5
Whatever.
over
Yes.
8
Yes.
equals x.
Equals x. So now let's approximate. So I will put this in the calculator. Here it is. So e, here is e to a power. E alone without power is right here. But I'm going to use e to the power. And in parentheses, you know me already, 45.5 divided by 8. And then I divide the whole thing. No, that's it. Was already included. So enter. So 200, so x equals. So we got that the critical number is x equals 295.15481. Okay. So remember what I wrote to myself. This is the number of units sold in thousands. So this will be 295,154 units. But I don't know what this gives. I cannot conclude. I have to study the sign of the derivative. Who knows what this gives? So this is the revenue prime. This is 295, one or the other, it doesn't matter. 154.81, okay? And I need to study the sign and see what happens to the left and what happens to the right. I know that this is 0. So, for example, 1. The easiest thing to plug in is 1. How come? Because natural log 1 is 0. So this is 0. So this is positive. Now let's see what happens here to the other side, like 300. So when I plug in 300, this should be negative. I'm going to calculate. So negative 8 natural log of 300 and plus 45.5. Let's see. Yes, it's a negative number. Good. So this appears to be a maximum. Now let's see if there are other restrictions here. Let's go back to the problem. Oh, where is my problem? Here. Is there any price at which revenue will be maximized? So this is X, right? But they're asking us about the price, so I have to calculate the price now. Okay, so the price, let me refresh your memory or refresh mine also. The price is this, 53.5 minus 8 natural log X. So the revenue appears to be maximum when we manufacture this number of units. But now let's see what happens to the price if we want to manufacture that amount. So P of 295.15481. I'm sure it's not going to be needed so many decimals, but let me go back. Here it is.
Wasn't that number just e to the 45.5 over 8?
Exactly. So that would be 45.5. True. So that, because when I plug it in, yes, that's absolutely true. So let me write it. So 53.5 minus 8 natural log to e 45.5 divided by 8. When I plug it in, put it in, it will be 45.5, right? So then the price will be 53.5 minus 45.5. That will be the price, which is $8 per unit. Is that what you meant?
Yep.
Because that was our x, 45.5 over 8. And there is an 8 in front. So when I bring this down, the 8 will go away. Natural log e is 1. And we just get negative 45.5. So that will be $8 per unit. So now let's see. Where is my problem? Okay. So demand for a new computer game. Okay. So an X is the number of games sold. Yep. So if we sell 295,154 units, the revenue, computer programs, the revenue will be maximum, and the price has to be $8 per unit. But we have to sell 295,155 units. Good pick. Anything else? Anything else? You want to look at forgetting?
Yeah, that sounds good.
Good. So let's look at forgetting. Students in the botany class took a final exam. They took equivalent forms of the exam at the monthly intervals thereafter. After t months, the average score, okay, S of t, of time, 78 minus 20, natural log of t plus 1. Of course, time greater than or equal to 0. And time is in months. Okay. Good. What was the average score when the students initially took the test? So what does that mean? What are we asked to find? What is the average score? So this is the average score when they took the test initially. What do I need to do? When we talk about initially.
0.
Exactly, of course, S of 0. 0 plus 1 is 1. Natural log 1 we know is 0. 0 times 20 is 0. So this must be 78. And let's look again and see the 78 as a percentage. Okay, so percent. Part B. What was the average score after 4 months, and then after 24 months, and after 24? Okay, what percentage of their original answers did students retain after 2 years? But that's 24 months. Okay, so we want to find S of 4, and we want to find S of 24. And then find S prime. So first, let's go to the calculator, put in y equals, clear, anything else, 78 minus 20 natural log. No, I didn't mean that. I meant this. Natural log of x plus 1 and close. Let me check. Yes, yes, yes. Perfect. So now second and table, and we want to plug in 4, and then we want to plug in 24. So 45.81%, and the other one 13.62%. Good. So part B we have, part C we have. What percentage of the original answers did the students retain after 2 years? How do we determine that? Anyone? So that's part C. What percentage of the original? So I'm on page 11. What percentage of the original? So we have to divide by the original. So how do we do that? So the original was 78. So this is original. Now, after 24 months, we have 13.62. So we have to find 13.62% of that.
You're still sharing your screen.
Oh my goodness, sorry. Sorry, thank you. Okay, so the original is 78%. That was the original score. And now they're asking us, what is this out of that, of the original? So we just have to write 78 times 0.1362. So that was 13, right? 13.6. What percentage of their original answers did they retain? Right? So that is 10.6236. Let me look again and see one more time. So what percentage of their original answers? Took an exam, they took equivalent forms of the exam. Okay, after 3 months, the average score, yes, as percentage was found to be. What was the average score when the students initially took the test? Yep. What percentage of their original answers did they retain after 2 years? So their scores now dropped from initially 78 to 13.62 after 2 years. That's what we got, right? So before and after 24. So it was 78 minus 20 natural log of x plus 1. Yep. I'm checking all my, so that's 13.62. Yes. That's the way I understand this question. What percent, how do you understand it? What percentage of their original answers when the students initially took? So this is my understanding, or just which is basically 78. So what percentage of their original answers did the students retain after 2 years, which is 24? So they were retaining 13.62. Right? The average score dropped from 78 to 13.62. So what percentage from the original they are still retaining? It's a little bit of a weird question, to be honest. So that was the average score. What do they mean by the original answers? Are they talking about the initial score test? The test score, or what? I'm not really sure what they mean by this.
I just looked in the back of the book, and it says that it would be, it's 130, right? Yeah. So it said it would be 17.4%.
But my question is, when they say out of the original answers, what does that mean?
I'm not sure.
It's not clear to me.
It's 13.62 divided by 78.
Out of the original. I see.
Yes.
Okay. So they consider that the initial is the original in that case. So
Correct.
13 divided by the original, 78. It's a little bit confusing with the initial and original. I didn't. Okay, I see. 0.1746, so it is 17.46%. When we are asked to find, so the question says of the original. So when we talk about of the original, it's a multiplication. That's why I was thinking of multiplication. Every time we say what percentage of the original, that's what we do. But what they are really referring to is not percent of the original. Basically, they should have put it in a different wording. They should have said not percent of the original, but
No, yeah, that tracks, because it's like if percentage of the original is our x that we're trying to find, it's x of 78 equals 13.62, and then solve for x.
That is a good point, because that's what of means. It means multiplication. Okay, I will go with that. I'm just erasing that product, but of always means multiplication, but I understand that they're asking us to find the percentage that results in 13. Got it. Thank you so much for clarifying that. And find S prime of t. Oops. Let me stop here and we'll finish. I don't want to hold you over.